Hi class, in this video we'll be talking about the engineering design process in chemistry. Let's say we know what properties our spoon must have and what additional properties it must have. How do we then take these ideas and create the actual product that we'll be using? So to do that, we have to design something. We have to use what's called the engineering design process. And in this process, we can develop multiple solutions for a problem and optimize those solutions by doing tests. And if the tests are successful, we'll know we have a solution that's viable to fit. So we use this kind of flow chart by identifying problems, doing research, defining and delimiting the problem in terms of criteria and constraints, making sure the problem's well defined so we can move forward to brainstorming solutions. After we brainstorm several possible solutions, we evaluate them with respect to the constraints and the most important criteria. And then we choose one or two to move forward with for testing. We'll develop and test a model out, and if that model fits the criteria and constraints after testing, we move towards optimization. And if not, we go back and brainstorm some more. So this whole this whole solution is very circular, it's flexible, you can move back and forth. After we have a good solution that passed the initial testing, we redefine the problem if we need to, and clarify the most important criteria. We consider what trade-offs we need to make so we can make those criteria. And then we build and test a prototype, and we refine, and after testing of the prototype, we refine it further till we have something that's really capable of solving that problem with the best budget and within the time that we have available. So some of these words in this process might be confusing. We talk about criteria, which is the singular form for criteria is criterion. Criteria are goals that tell us whether a solution is successful and how efficient and economical that solution should be. Whereas constraints are the limitations of a design. These are often but not always provided by the client. So for criteria, sometimes we think of budget, sometimes we think of the main things our solution must have. And constraints, we often think of things that we definitely need to avoid, like safety, product safety, and limitations of resources that are available. And it might also be a budget constraint. Sometimes our criteria might be we want it to be low cost, and a constraint would be it definitely cannot be over this amount. So these are somehow interchangeable in some scenarios. So as a chemical engineer, you apply chemistry to real-world problems by finding solutions. So sometimes you work in a lab, sometimes you do research, sometimes you test out problems. Chemical engineers develop useful products and chemical processes for society in the most efficient, environmentally sound, safe, and cost-effective way. So these are some big words here for developing our criteria and constraints. Efficient, environmental conscious, safe, cost-effective. Always want to think of those things. when we develop solutions. Let's suppose that you're a chemical engineer working with a client and they want a blue stripe on the toothpaste. And they want a minty flavor stripe here. What questions might you ask to begin designing the solution to this problem? Think of some questions, like 3 questions. So let's think if these are criteria or constraint. The blue stripe must be visually appealing. If the blue stripe must look good, that's definitely part of our solution that we want to have. So I would say criteria. Adding the blue mint flavor stripe must be below a certain cost. So there's a budget cap. If it goes above that cost, it would be bad. So that's a limitation or constraint. The chemicals in the blue stripe must not react with plastic. Okay, is that a criteria, something we want, or is that a limitation, something we must avoid? The blue dye cannot cause the toothpaste to foam blue. Is that a criteria that we want to have, or do we want, or something we want to avoid? You might also consider trade-offs when we're in the engineering design process. Trade-off is an exchange for one thing in return for another. We might give up one benefit in favor of another to avoid a potential risk. Like if I use this ingredient for my toothpaste to make a bunch of foam, but the ingredient I chose is corrosive to plastic, that's not a trade-off that I can accept. But if it raises the cost a little bit higher, but not above my threshold, maybe that's a good trade-off. So what would be some criteria that are important when developing a product such as a toothpaste? What trade-offs would you consider making to ensure that your most important criteria are met in your final design solution? Okay, so you want this nice blue minty stripe toothpaste, nice and blue minty stripe, maybe even a red stripe. How much would that add to your costs? And is that okay? The customer said they wanted 3 stripes, but it would raise the cost too high. Is that a good trade-off or not? So one way, let's say you have a solution, one way to optimize and test design solutions is through user testing. So if I'm a chemical engineer and I developed a prototype toothpaste with the blue minty stripe, my testers could provide me with information about the flavor, the amount of foaming, and the effectiveness of the toothpaste. This information could be reported qualitatively through interviews or descriptions from the user testers, or this information could also be reported quantitatively by having users report their experiences on an opinion scale, say from 1 to 5. Let's add details to our evidence notebook that would help support our claim about the criteria and constraints that our edible spoon should have.